Hello, 8th grade. Today we're going to be talking about how to find some special products of binomials. So just a quick reminder what a binomial product looks like. When you have something like a plus b times c plus d. And what we would normally do with this is FOIL it, going through FOIL, and then we would plug in all the first letters, a, c, the outers would be a and d, inners would be bc, and last would be b and d. And we would add all these up, AC plus AD plus BC plus BD, and that is how we would find the product of this thing, which is very effective and it works every time, but there's a couple cases where we can look at things like this and kind of get the answer a little bit quicker. So I want to show you guys what those two cases are. And our first case is going to be squaring a binomial. So what this is going to look like is if I have something like x plus 2 squared. So what x plus 2 squared would be is x plus 2 times x plus 2, and that's going to give me, my first would be x times x, so that's x squared. My outer numbers would be x and 2, which would be 2x. My inner numbers would also be x and 2, which would be 2x. And my last would be 2 times 2, which is 4. I add these up and I get x squared plus 2x and 2x make 4x. Just combining our like terms there, plus 4. And we want to remember once more that we cannot combine our x squared and our x. Those are not like terms. So x squared stays by itself right here, and the x comes right over to there. And this is going to be what we end up with, is x squared plus 4x plus 4. But to be honest with you guys, there's a much easier way to do this. If you see a binomial that looks like a plus b squared, it's always going to end up as a squared plus b squared plus 2ab. So where that comes from is a squared is going to come from the firsts, b squared comes from the lasts, because if we take a times a, that's a squared, and b times b is b squared. Then we have this 2ab, and I hope we're all wondering where this 2 came from. Where it comes from is one of them comes from the inner, and one comes from the outer. If we look here, the inner and the outer are the same, so it doubles, and we have 2ab. And that's what this is going to be. So this right here is going to be one of our two special cases for today. Is a plus b squared equals a squared plus b squared plus 2ab. I want to try that on a couple practice problems. So if we try, let's do 2x plus 1, the quantity squared. I should be able to take the first term, which is 2x, and square it. So 2x squared, 2 squared is 4, x squared is x squared. Be 4x squared. Add my second term squared, 1 squared is 1. And then add 2 times my terms multiplied together. So 2x times 1 is going to be 2x, multiplied by my 2 here will give me 4x. So my final answer would be 4x squared plus 4x plus 1, and I'm good to go. Didn't have to FOIL or anything, basically just did it in my head, which is very nice to be able to do. And one more practice problem just for fun is going to be, let's do x squared plus y, the quantity squared. So x squared squared is going to be x to the power of 4. We're going to add y squared, my second term squared, and I'm going to add 2 times my first term, which is x squared, times my second term, which is y. So I end up with x to the 4th plus 2x squared y plus y squared. And that's going to be my final answer. And again, these are not too difficult to solve. They just kind of happen naturally. Once you see the pattern, you can use it all the time. The second pattern I want to show you guys is what happens when I use, let me use a and b here like I did in the first one, a minus b times a plus b. So I have, what I have here is a sum right here and a difference. And anytime we have a sum multiplied by a difference, there's a special rule we can use. It turns out very, very pretty. So what we have here, my first is going to be a times a, which is going to be a squared. My outer is a times b. My inner is negative b times a, so that's negative ab. And my last is negative b times b, which is negative b squared. So I add these up. I have a squared plus ab minus b squared. These two cancel, and I end up with a squared minus b squared. So what this tells me is anytime I have a sum and a difference, I can take the one that's positive both times and square it, and then subtract the one that is positive once and negative once, square that, and then I have my final answer. So a minus b times a plus b is a squared minus b squared. Let's look at a couple examples again. So if I have x minus 1 times x plus 1, what I can do now is just take this x, which is positive in both, call that x squared, then subtract the 1, which is subtracted here and added here. 1 squared is 1, so x squared minus 1 squared would be my answer, and I'm good to go. Simplifies very nicely. A bit of a different one, just to show you guys this works too, is if I have 2x plus 3 times 2x minus 3. This time I did put the subtraction sign over here. It doesn't matter the order, it's okay. Is now the one that's positive in both is 2x. 2x squared is going to be 2 squared is 4. X squared is x squared. I'm going to subtract my second term, which is 3 and 3. 3 times 3 is going to be 9. And my answer is 4x squared minus 9. So that one's pretty simple. And after that, we're just going to be able to keep repeating this whenever we see one of these patterns, and instead of going through the long process of foiling, just use these patterns to be able to make our lives a little bit easier. And that is all I've got for today. A pretty simple lesson. I'll hope to see you guys in class tomorrow. Toodaloo.